Hello, welcome back to another episode of the Reliability Gang podcast. I'm here with my right-hand man, Will Crane. How are we keeping, buddy?
Doing very well, thank you very much.
Thank you for everyone that's tuned into the last two podcasts. We've had a real massive jump, actually, in the stats and figures. Now we're like regularly getting that kind of 100 downloads a week mark, which is incredible, really, because we're trying to keep them coming. We're trying to keep them coming, but also we're trying to make sure the quality's there as well as the consistency. So getting that balance between the two is great, and I think the aim is once every 2 weeks you will see a podcast. But I think we got really passionate the last two podcasts, didn't we?
Yep.
You know, we talked a lot, didn't we?
Well, we quite enjoy
I talked a lot.
we enjoy making these. That's the thing, and it's nice to talk about subjects. And sometimes, like when we're discussing them, we think of ideas afterwards. We come out of it and go, "Oh, that was a really good discussion point. That maybe we should do this and this." And we always come up with ideas off the back of it. So we enjoy making them, and when we get the chance to, I think every 2 weeks is a good. We always try and be a bit ambitious, don't we?
We do.
As us all over.
Yeah, we're going to do 10 podcasts a week. It's like just not feasible when you've got. We'd love to.
I think
we could do it, I reckon. I think, how much ideas and how much chat me and you have got about this.
It will become easier in the new year when we move the studio, though.
Yes. So that's some more exciting news, actually. So all of these podcasts are done within my home studio. As you all know, I love music and I produce a lot of bits and bobs. But what we all really want to do is bring this into the Maintain HQ. So we've had a few changes around, haven't we? And we've actually decided to build a brand new podcast room.
And videography
room as well, because we want to start doing some webinar stuff as well, don't we? And some like show and tell with the products. And it's already difficult when it's here. You know what I mean? If we had a place to do that in the office, I think we'd get a lot more content done.
Definitely. So that's exciting for the future.
Exciting news. Anyway, back to today's podcast. We kind of diverted a little bit on the last two, going into kind of more vibration analysis, looking at practices and strategy. What we want to do today is starting to go into an industry that's been highly successful for us, and it's one that's grown within our kind of portfolio. We want to really focus on the biogas industry, because it's something that we've kind of been working on probably the last 3 years, essentially, with one of our main customers, initial customers, Future Biogas, that we've worked very closely with. And that's evolved into kind of a new services package where we've kind of built this as we've gone, haven't we?
Yeah, it just started off as being, oh, well, we can use this service, and then, they could utilize that one as well. And then before it or not, we're calling it the biogas package, and we're doing lots of different things. And so we're kind of bundled together a lot of condition monitoring services that we do for lots of different companies, but we've kind of really tailored it for that industry.
Of course. And the thing is about the biogas industry, they're slightly different to the model that would, deploy when you're looking at a factory. I mean, generally, when you've got a manufacturing factory, you've probably got quite a multiple amount of days, unless it's a small factory. You have to really focus on VA strategies to understand what's important, what's not, to be able to really efficiently utilize your time. Whereas the biogas sites, generally, even the big kind of sites, don't have a huge amount of equipment. They have a fair amount and very important equipment, though. So I'd say the biogas kind of equipment, a lot of it is highly critical for the process. And generally, most assets on the site would cause it to potentially, affect dysfunction in some way or the other.
You've got those different challenges, haven't you? So like in a factory, you do have multiple days, but your challenges are more like, is this line going to run today, or do I need to tie in with production? Whereas the biogas sites, generally everything's going to run if the factory's running, but everything is fairly critical. Or if that stirrer fails, it's not just okay, we'll do a straight swap. A straight swap, we've got to now potentially drain the whole digester, and we're going to have to like do a quite heavy maintenance. We might need a crane. So everything's on that heightened level of criticality, and you've got added to that is you've got gas, you've got ATEX, you've got
environments,
you've got all of these things that and their equipment isn't just your straight conveyor. It's, we're dealing with, often planetary gearboxes. We're dealing with, gas compressors, screws, pistons, reciprocators, lots of complex
different, and it could be a different variation of compressors, because what we'll do later on is go through the process on how kind of the biogas site works, and also what equipment can be used to be able to perform similar functions. And sometimes them equipments can be completely different in how they can fail, which also kind of is challenging on the sense that You know, we've got to know different types of compressor setups, whether it's reciprocating or whether it's screw compressors, and different manufacturers as well will work sometimes slightly in a different way as well, you know, in terms of the way they operate.
And you'll also find within a lot of the biogas industry is a lot of their equipment, a fair amount, less so on the stirrers, but a lot of like the compressors and the feed systems and everything that we're going to go into more detail in a minute. A lot of it is single point failure. So if they lose the compressor or the CHP plant, the whole site,
the whole plant will basically stop production in the sense of producing that gas. And as well, when we look at kind of criticality, two of the main things we look at when we're even doing it on a site-based level is obviously health and safety, and obviously environment. And obviously them two things are highly impacted by a lot of the equipment on site. So this is where I think criticality is, you know, is very important in that sense, because everything's heightened because of ATEX environments as well. And I think this is kind of where led us our journey into that kind of process, because generally I think when we first kind of got introduced to Future Biogas, the sites were roughly around about 6 to 7 years old. And when they were first got built, again, usually it's a dream if you can get something like this set up from the get-go, because you can understand kind of what the new equipment looks like in terms of baseline readings. You can understand as well, not even that, you can kind of mitigate any kind of infant failures in that first period as well, you know.
You can build for reliability as well. Like even we'd have challenges when we go to monitor some of the compressors because they're in a cabinet like this big, and you're like, it would have been nice if it was a bit bigger. And you can influence, you know, we talk about when we do ARP training, how at the start of a project or in that design phase, you have a much greater influence on the reliability than you do once the project's complete.
And it's the maintainability of that plant as well. I mean, we're now dealing with another customer, you know, materials change, incredible customer that we've actually started, you know, last couple of months. And we've already identified some great issues, but now the Solve team's getting involved. And it's like, well, how do we even lift this out of here? Because the way it's been designed has not been designed for these things to be maintained. So you have to be a little bit more creative, and obviously, you know, in terms of getting some of these things done, because changing the bearing is not difficult, really, it's not. But when you have to do a complex lift, that's when the difficult element of that comes in. Do you know what I mean? Making sure we can do it in a safe way and obviously a reliable way is always a challenge. So maintainability is always something, but inherently from the start, generally when we started here, it was roughly kind of 5 years to 7 years in the project. And they started to have failures, you know, unexpected failures. So, you know, compressor might fail, for example, or compressor bearing might fail, or motor bearing on the compressor could fail. And it was causing them extreme upset in terms of production as well, because what would happen is, generally some of the ADI compressors that they've got, the motors are not small, are they, Will? They're some quite big beasts to be able to really compress that element, aren't they?
Yep, they're big motors that they are in a cabinet that's tricky to get to. It's got pipe work all over it. They are working very hard because they are trying to compress gas, and at every opportunity they have to make them work a little bit harder. They do, because they want to get as much gas out of the plant as they can. So they're big motors, they're tricky to access, and they are inherently, they're on variable frequency drives, and they're very noisy from electrical noise points. So that
can be challenging as well. And I think that was really our introduction to biogas, really. It was vibration analysis that really opened the door for us. And you know, as we started to build a great relationship with Future Biogas, we ended up doing more, and we ended up doing it more regularly, because obviously inherently when we first started, we wasn't doing it enough, you know, but you got to start somewhere within this. And if you haven't been introduced to vibration analysis before, you got to try it a little bit to see kind of
Future Biogas, it was quite new. So when we first started off, we were doing, you know, a visit with Neil every other month, and then we started identifying a few things. And then we started identifying more things, and then they were having a failure off the things that we were identifying. So we then, the value was then being driven. Then they were like, these guys are identifying stuff, and we need to start doing what they're asking us to do. So then it became, maybe we should really do this more frequently, because we know that ideally vibration analysis, we want monthly readings to trend, especially for the ADI compressors at the time, which we were monitoring with handheld data, where when you've got a machine like that, which is, you know, 1 month they might be running it at 50 hertz line frequency, then they're going to overclock it a little bit and try run it a bit harder because they've got, you know, a gas demand or whatever. Your trends are going up and down like this,
and that's
especially month. And then you've got a gap, and then, and especially when you do it bi-monthly, you know, we really needed to get that monthly so we could start trending that a bit better.
100%, and that's also kind of comes in a lot of the VA strategies we do now. Is like, does the machine run consistently? Does the machine have variable load, variable speed? And these are the things that can be challenging when you're trying to be able to trend something or whatever you're trying to test on the test by test basis to make sure that you get repeatability. So yeah, that's when it kind of evolved, and we obviously did a lot more. And then we got involved with optical gas imagery, and this is another. I love this service that we do, and what we can, the technology involved with it is extremely high tech. It's extremely advanced in terms of what we can find, and the camera that we've got now is extremely sensitive to be able to find them gas leaks. So it was kind of like a big eye opener for us, because at the time we recognized it was such a service that these guys needed, and I think we got asked, can we do it? And I think it was a case of like, right, well, Will's is tweaked up a bit, geek mode come on. It's like, right, can we do this service? And we looked into getting the camera, and I think you really particularly enjoyed this part of the service.
Because it was a case of we knew of optical gas imagery back from like hearing it in the grapevine.
Yeah, because I remember even my ATEX days, they did some of it. But it wasn't really biogas industry orientated. It was more looking at kind of like oil and gas, that was kind of the industry. But the cameras at the time
were very expensive.
Yeah, they were using the FLIR camera at the time, and I think they invested, about £120,000.
Well, that's it.
You imagine being a small business, it's not feasible, is it, at the time? We're very fortunate now that we've able to buy an OpGal and supply the OpGal products, which is incredible. And it's crazy to see that journey from where we started as well. And we didn't have that camera firstly as well, did we, Will?
I remember we being approached by Future Biogas at the time and sort of saying, yeah, we'll have a look into it. And I think when you start to realise, and it's probably a whole nother discussion, that there's a lot of similarities between infrared thermography and optical gas imagery.
That's another podcast, guys.
So there's a lot of similarities there. They share a lot of the same principles. You're like, okay, well, I've already done my infrared thermography. I get a lot of this. And then it's a case of, okay, well, we know these cameras are very expensive. How do we then start to be able to deliver the service? And that's when we then stumbled across the FLIR GF77, and a little shout out to you at Ascentec. And we started thinking, no, actually this camera, it's built by FLIR, it's designed for the biogas industry, and it's got a price tag that, as a small business, when it was just really you, me, I think Jamie at the time, is something that we could actually offer. We could get the camera and we could begin doing it. And that's where our optical gas imagery journey began. That's when that kind of begun.
And obviously with the optical gas imagery, with the GF77 at the time, was a great thermal camera as well. And that's another really important thing to measure as well, is panel health within these biogas sites.
Yeah, because we could do it at the same time.
Exactly. There's not many on the sites that we find, but it's such an important metric, because again, if you look at failure modes, if you've got a contactor that goes out on a critical motor,
you had one at Eco Verde, didn't you?
Yeah, we did. Yeah, we found some really good stuff there, and we utilised that with Eco Verde as well. A lot of thermal, and a lot of more of OGI kind of work that we do with them guys. But yeah, really, really good finds for them, and these things would ultimately ended up in failure, causing the plant to stop. And usually, when you get electrical faults, depending on whether this might be main incomers or whatever, if you've got kind of poor resistance joints, or you've got cable, it's not a quick fix.
No.
You have to get a proper,
you have to pull the cable out, you might have to do all sorts, and
you have to be careful as well. Obviously, you've got to have complex engineers available as well. You've got different kind of constraints with it as well. So finding them faults early is extremely important, and obviously that combined with the OGI surveys as well. And inherently, usually when we first started, again, this is another argument even on the manufacturing basis, that these things should be done more than once a year. And I put a post out on our LinkedIn actually the other day on our maintain page about the importance of doing more than one survey just to be able to warrant your insurance purposes.
Particularly with thermography, we see that quite a lot.
Yeah, particularly with thermography and optical gas imagery. And now there is some kind of rules around kind of OGI and how often it should be done. And, I think we're going to start seeing them rules come in, that has already to a degree that once every 6 months is kind of the requirement. But we think that should be standard anyway, and I don't think you should just do things out of the sense of, is it the requirement? we should be doing things out of the use case and the risk, if that makes sense, a risk assessing these things.
Well, interestingly, I was watching we obviously look into quite a lot and follow the industry quite closely. And I was watching a video by, I think it was the Infrared Technology Centre. And there is some more guidance and documentation more in the US than over here, actually, because I think they're a bit more involved with like petrochemical and gas sites and stuff. But that they showed a document that was on risk basis. And it was like gas and screw compressors every quarter.
Oh, really?
Then,
Okay.
yeah, and then like other parts of the plant, less so important, maybe twice a year and stuff like that. So I need to do a bit more digging and have a look into
that. And that's why as well, when we start to evolve these packages within Future Biogas, me and Will thought about, well, how do we actually really apply proper service to this?
Yeah.
Because as well, sometimes if you're getting one gas survey, OGI a year, well, what happens if you find quite a few leaks? Well, you're going to have to now pay someone again to come back to verify them leaks have gone. And say if they haven't gone.
Yeah.
You know what I mean? So the verification process became extremely difficult for sites, and on the service, that is quite a lot of money because the equipment's high. So when we started to think about this, what we did is kind of combine these packages. So, okay, you'd still maybe do 2 OGIs a year within that contract, but you've got monthly vibration analysis. And say, for example, repairs have been done and, we've got the camera available. Are we able to maybe just check a few? Of course we are. And this is also why the package becomes so attractive, because if you have a think about companies that are just doing OGI with a separate company and not really having the regularity on site, then they're having to again obviously keep paying premium costs to get the camera out, because ultimately if you call the camera out, it needs to be allocated for that day anyway. Yep. Does that make sense? And I totally get that from a business point of view if we just did OGI purely, but because we do offer all them other services around it, allows us to be able to have a relationship with that site. It's a little bit more kind of,
closer, isn't it?
It's closer. Yeah,
we're there. And when we're there every single month doing vibration analysis, we can, offer advice on the lubrication. We can then, all we're then managing is not the fact that, we've got to have an engineer doing an OGI. We're just making sure we've got an engineer there every month anyway. What's the logistics around the camera? Can we get it over there? They want to do a check on it.
And 9 times out of 10, generally we can fulfill that. Do you know what I mean? Within a quite quick turnaround. And this is the other thing also as well, when you look at kind of maintenance on these OGI sites, generally what you'll have is the site's not huge, not massive. Yep. So you won't have really an engineer at each site. You might have a large portfolio and you might have a company that kind of looks after, running and the maintenance of a selection, but they won't have an engineer at each site. It's not really feasible.
They're on the road, they're field engineers, and they will go to whatever site they're needed at on that day.
Exactly. So that also makes our presence a little bit more valuable in the sense that if we can be the eyes and ears as well on these monthly surveys, what we can do is prep and prepare the maintenance team to be able to do some of these things when they need to, rather than just kind of come into site as well. And what we are finding, especially with this industry, that preventative maintenance has always been a big thing. So the thing is, with a lot of OEM kind of recommendations, a lot of things are based upon schedule or time or run hours in terms of how we should perform the maintenance. And a lot of the time what we're finding is unnecessary changes of equipment that doesn't actually need to happen from these kind of schedules. So when we've kind of looked at it, we've really tried to promote more of a condition-based way of doing things. Because it's not cheap to just go replace 10 stirrers at your site.
It's a mindset change as well. So a lot of these sites, like Will said, they're on a preventative maintenance. We change that motor on the compressor every 10,000 hours. Why'd you do that? Because the OEM said. And we see it in factories as well. It's not just the biogas industry, but fundamentally that there is a big trust that I think people put on the OEM. And, all we're saying is we're not saying don't trust them, but question them. How did you come to that 10,000 hours? Can you show me maybe the FAMICA that you did to determine that's what needed to happen? Because what we'd like to do is maybe change this to condition-based. And we had this as well within the marine industry back when. We've used to do a lot of work in that industry where they were very preventative as well. And that industry had always been, but then the classifications like DMV started to change their documentation to say, well, actually, if you do start doing condition monitoring, we're going to not tell you that you need to do all of this sort of stuff, because you've now given me us justification as to why you're doing that. And I think we're starting to see that shift a bit in the biogas industry.
Yeah, I agree, and I think that's where we have to think open-mindedly, and we've got to think more proactively, because when you're looking at kind of the replacement of multiple pieces of equipment that are quite complex, the cost of that can be extremely expensive. So if we can start looking at ways we can monitor more effectively, or maybe use some of that money to be able to employ some wireless like monitoring or online monitoring, whatever way you want to do it, that allows us to monitor more frequently, then we are then reducing the risk further, because at least then we are actually seeing these things more regularly, and we're actually able to keep a finger on the pulse. So, even us, in terms of looking at kind of our setup, generally we'll have an engineer each month go to site, but also we'll start to look at ways we can actually incorporate maybe an MVX system to look at the compressor, because then we can keep a finger on the pulse all the time. And as well, with a screw compressor, the failure rate of them can be very fast.
We saw it on the one that I put
We
on
did,
LinkedIn.
yeah. So we recently did a really good trial for another biogas company, and we've actually seen a failure from start to finish within a 2-week period, and that's something that would not have been captured in the monthly survey, which is quite ironic, really, because when we looked at that, we were aware of how fast they can fail, but I don't think we actually knew how quick that actually could escalate.
No, and I think that we've spoken with the engineering manager there, and I think that had we had that system on longer, we might have seen it earlier. But
you're right. We don't know.
We don't know that.
Yeah.
But either way, with screw compressors, we know that from the point of potential failure to functional failure can be very quick. And for something so critical and something so important, I think we are going to start seeing, even with our existing biogas customers, that start to shift now, to start looking at, okay, well, can we move to a better monitoring solution on these really important assets?
I agree. And also, if you could imagine as well, obviously the cost of online monitoring is getting cheaper now. The cost of it now, opposed to what the risk of failure is, that gap is getting bigger.
Yeah,
you know what I mean, especially with the biogas sites and the importance of the compressors.
And post-COVID as well, where spare parts were no longer on the shelves anymore.
Yeah, and do you know what? You've hit the nail on the head. I think, how many times have we spoke to this particular industry and parts and lead times on some of this equipment? Because remember, some of the equipment or motors or mixers or pumps are actually built by certain manufacturers that will build for the biogas industry.
Often in Europe as well.
So like some Pimo pumps, but, they do a pump that looks to be able to feed the product into the digesters. It's a particular kind of process, because it's a matter that also is quite unique, so it's designed to do that. But that also means that stock is held within Europe.
I remember that compressor that we picked up with the MVX system in the trial. I think that was a phone call of, you need to get this changed as soon as possible, and that was right. Well, we're going to have to get a new.
I think that was the service company was kind of.
Well, they were going to ship it from Holland.
Yeah, it was. Yeah, so again, that's another thing as well. How do we need to be on the button for this? You know what I mean, to make sure that we can plan these things, and not in terms of just the maintenance, but the actual supply of equipment, if that needs to happen as well. So that's a really incredible kind of way that we can mitigate a lot of this, and I think this is where the value started to increase massively when we started to look at these extra services as well. So moving on kind of from that, I think it would be really cool, Will, for you to describe a little bit of how the biogas operation works.
Sure.
How does it generate its methane? How does that benefit the people, the community, and things around it? And also, how is it kind of sustainable and also kind of renewable?
I'll try my best. I'm not a biogas.
We're no expert, but I think it's quite important to add context.
Yeah, you need to have a little bit of an understanding. As with any place we visit, we need to understand how the plant operates, because it lets us think about the
how it can fail. Yeah, of course.
So the way the biogas plants often work is they have a feedstock. A lot of the sites they feed maize, sugar beet pulp, anything like that, organic matter, essentially. So they get that all in during a set period of time. So right now they're in harvest. So they're cutting all the maize down. All the farmers are cutting the maize. They're bringing it all into the biogas sites, and they're clamping it down. They're putting it in big clamps, and they're covering it up.
But I see all that storage around it.
And what that does is that allows them to hold that stock for the rest of the year till the next harvest. And what they're going to then start doing is they're going to start scooping it up in a big shovel and start putting it into a feed hopper that's going to feed the digester. And the digester is where the first part of the process begins, where they're going to start. It's a very balance, from my understanding, in the digester, and it's about having the perfect conditions for the bugs to thrive. And these bugs are going to start eating at all that organic matter. But this is where it's really important. So that digester is heated from the CHP plant,
of course,
to keep the right temperature. They've got a lot of parameters that they're monitoring there. It's being stirred with stirrers on the top to keep it in that perfect environment. And if any of that's wrong and they lose the environment, they can risk killing the bugs.
Right, so then that would obviously deter from them. Yeah.
They can't produce the gas, but also, from what I've understood, talking to Gil and some of the other guys within the industry, if they kill the bugs, it can take weeks to get it back up again.
It's a bit like when we went to that site with the effluent, with the bugs and stuff like that, how they broke that down. It's very similar kind of that, wasn't it?
So if they lose that, they've got to keep that right. The CHP plants, they have a CHP plant, most of the sites where the gas that they are producing is powering that's giving their electricity and their heat. And then you usually have some form of post-digester stage, which I think is, I'm not massively familiar with exactly what they do in the post-digester, but I think it's just more gas extraction, mainly, because usually the post-digesters are what you see with the big domes on top. If you ever drive and like up the A1, you can see a lot of
you've
these
probably seen these somewhere. But what do they actually do? Well, now you know.
So the big dome, that is they're capturing the gas in there, and then that gas is then often going to some form of gas conditioning. So it might be going to a gas booster, it might be getting scrubbed and cleaned before it's then sent to one or two things. So some of the biogas sites will be what's called gas to grid. It will go to a screw compressor of some description, and that gas is then, essentially, the simplified version is it's put to the grid. Ultimately, if it's gas to grid, it will be mixed with a little bit of propane. They add an odorizer as well to let it have a smell before it goes to the grid. So some sites are gas to grid, some are purely just CHP, and all they'll be doing is power generation. And they'll just have several CHP engines generating electricity for something. But these sites, they're ultimately, as long as we keep all the gas in, and they're very renewable, so we're using an organic matter to generate gas, we're not having to drill, we're not having to do any like fracking or anything like that. They're fairly self-sufficient, they generate all their own power, and they take up quite a small amount of footprint. So
that's another thing, isn't it? The footprint of a biogas site, it's actually really small, isn't it?
Yeah.
Like, to be able to actually have one.
But they can help a lot of like Will mentioned on the communities and stuff, they help a lot of things. We've got a biogas site local to us in Norfolk that produces a lot of power for a local airbase. We've got the one that Jamie's at a site today, and they actually do a lot of the heat and power for Centre Park.
That's cool.
Yeah,
that's
so cool. They can be a highly good renewable energy source that isn't reliant upon elsewhere. We saw during a lot of the news over the last few years where we've seen gas prices increase quite dramatically because of world affairs. The biogas industry in the UK, as long as we keep the farmers happy and stuff that, they can be fairly good. But it's not just feedstock and things like that. You can do anything. I mean, we've got sites that do chicken muck, they do food waste.
There's quite a few.
Anything that can be broken down and eaten by bugs, we can put it in a digester.
And that kind of moves us on to the next point of what services, and again, generally the services that we provide will ensure that we can kind of mitigate some failure modes of some of them functions that Will was talking about. So obviously, we spoke about before, vibration analysis is extremely key for the monitoring of all of that equipment. So the compressors, the feed system as well, because if you're not feeding in, well, then you're not be able to produce, as well. Obviously, the heating elements around them conditions, all of this requires machinery. And generally, what vibration analysis allows us to do is to check how that machinery is operating and the condition of, the bearings within that machinery as well, the running conditions of that machinery as well. If you've got gas boosters, is there a slight imbalance within the impeller? Is there, pumps or issues with bearings and pumps, or gearboxes as well?
Belt as well is a big one.
Belts is another one as well. It kind of then leads us on to oil analysis, another really
big important one for this industry. So, we have got the biogas industry as well, is an industry where its equipment can range from 3,000 RPM gas compressors down to gearboxes that have an output of 6.
And that's the problem.
Right.
When you've got such slow output speeds, vibration analysis loses its kind of effectiveness really. So then we have to rely on other ways of being able to monitor things. So oil analysis gives us a really good view of any wear particles within that oil, and also any kind of conditions where the oil might have broken down and not able to do its job correctly, which prevents the film within the mating parts of the gearbox actually start to fail.
Exactly. We talked about thermography earlier, but thermography is really important here as well, because they don't have a lot of panels, but we need to make sure from a reliability perspective that we are mitigating any potential failure due to an electrical contact. But also, generally with thermography and electrical faults, when we have a loose connection, we get a lot of high resistance. High resistance gives heat and gas don't mix.
Yeah.
Kaboom.
Yeah, so, exactly. You have to remember, obviously, a lot of these sites in some areas are ATEX rated as well. So you also have to mitigate that. And also thermography just on motor temperatures, on bearings, and it can be a really effective tool just to be able to give a more oversight.
And that's where it's really nice that we do a lot, not just the biogas industry, we do a lot of work within we have a couple of coma sites and chemical plants that are doing a lot of what's called MIRA, which is the mechanical equipment ignition source regulations, something like that. But what that looks at is saying that some of this equipment, might have seals and different parts of the equipment that could potentially be an ignition source, and we can use thermography to look at seals to make sure we're not getting a high heat spot or anything like that.
Yeah, definitely. So they kind of use them technologies to really mitigate that within the environment is extremely important, because when you've got obviously an explosive atmosphere, you're trying to reduce the risk of anything that could potentially cause ignition across the whole site. So this is where vibration analysis is extremely powerful, and thermography for that, because what we essentially looking for, metal to metal contact within our bearings is something else that we can identify with our envelope readings that we take to make sure that that's not happening, or if it is happening, we need to do something about it as well.
Yeah. Lubrication is a big one in this industry as well. So inherently, Will said a lot of these sites are fairly low in terms of the people on site. There might be maybe 2 operators at a max, and they need to run the whole site, lubricate the whole site, and that can be challenging. And so we're able to support with that. We're able to use the lube factor on the analyzers for a lot of the high-speed gas boosters. Just top up the grease, make sure it's sitting right, but also offer a lot of advice and support. Do we need to put that much grease into there? And we've had it recently with auto greasers as well. I don't want you to get too. You're very passionate.
I'm ready to go, but even that inherently though, and this is another thing about lubrication. We can do a whole podcast on it, but real quickly, I'm going to go real quick on this. That generally with lubrication, it seems that there's a kind of ongoing theme that more and more and more is good.
Better. Yeah, just put
loads in. Let's go more and more. Well, if we overdo it a little bit, we're never going to underdo it. I'm telling you categorically right now that you can kill your machinery a lot quicker with over lubrication than under lubrication. And this is something that we've seen at a site recently. And again, it's a touchy one, because generally, what you'll have on some biogas sites is some companies potentially looking after parts of it, or, service contracts.
The service contract, or the gas compressor.
Yeah, of course, 100%. So, this particular occasion, we had a service company looking after the compressors. And don't get me wrong, when it comes to the compressor,
yeah, we have no idea.
We don't know.
Making the gas bit.
The gas part is obviously very specialised. But when it comes down to the maintenance of the bearings and the maintenance of the lube, we do know. We're experts on that. So when you see, self-lubricate is set to 12.
Or 0.
Or 0. Or you see a self-lubricate on the non-drive end set to 12 and nothing at the drive end, it does beg the question, what's going on here? This is definitely not right. Then also when you see that the fact that the lubricant within the motor is a
different
Unirex, and in the self-greasers, a Polyrex, we've gone through this again on another podcast, they don't mix, guys. Them thickeners hate each other. Horrible relationship, that. Complete reaction, and cause, obviously, the failure. But not even that. When you set the self-lubricate at 12, just give you an idea as well, this particular motor, even on nameplate, said it needed 3 grams roughly a month per bearing. So that lubricator is 120 grams. And it dispensed half of its matter within a month. So it dispensed 60 grams right? And it should be getting free. So where's that grease going?
Oh dear.
Oh dear. So this is why, though, it's so important, because remember, proactive maintenance is going to be able to allow us to be able to get that reliability element offering. We don't want to just come to these biogas sites and identify problems and not improve the reliability. The reliability ethos within maintain reliability is still there when we go to the biogas sites.
Yep.
So a lot of our value is not in the sense of detecting problems, it's in the sense of improving maintenance practices across the site. Because generally, you might have a maintenance team, but again, when you've got lots of different sites scattered all over the place, you're not really going to be thinking of them individual strategies. So what we can come and do is look at the VA, look at all the packages that we offer, but also offer the expertise in and around lubrication that allows us as well to potentially take over the lube schedules and do it on a condition-based schedule. That means we can lubricate when our machines tell us that the friction level, or our ultrasound device tell us the friction level is high at a very early stage of that lubrication process. That allows us to be able to lubricate these assets a lot quicker until it gets to a problem or issue, but also never to over lubricate, which is a common theme that we're finding. Self lubricators, if set up correctly to the T, I'm not dismissing them. But the problem is we kind of chuck them on and leave them, because as well, a lot of the time, if you put a self lubricate, are you checking that? Are you checking this dispensing? How many times have we seen self lubricators completely over lubing or just no lube in there at all?
We do the self lubricators with Grootsner, but we generally, we only sell those to the customers where we have monthly contracts, because then we can look after them.
100%.
We can check them, we can inspect them, we can see that that's not working this month. We need to do an.
We're not here just to sell the product, are we? And that's the thing as well. We're with it. We obviously, I get that other companies that will sell these things that want to look at the volume sell, but we don't want to do that if it's going to really potentially affect the reliability.
You could do the volume sell and actually end up killing the machine. But ultimately, what we want the biogas guys to do, we want the operators to do, we want the operators to focus on keeping that digester nice and happy making gas,
because they're the experts.
They're the experts. We want the maintenance teams that are within the biogas companies, want them focusing on doing their PMs and their maintenance tasks that they need to do. Let us be the future pointing at the direction. I think there's a great graphic within the vibration analysis and condition monitoring training we do as part of Mobius, where it's like a whack-a-mole, and it's without condition monitoring, without reliability, the maintenance teams are like trying to hit the moles, and they don't know that they're coming and they're whacking them all over the place. But what we want to kind of be is both with vibration analysis, the thermography, the oil, the leak detection, is be like, guys, you've got a leak over here, guys, this asset's going to fail soon.
We're also like putting a flashlight on these moles.
Yeah.
And we're eking them out so they can get whacked.
Right.
And I think this is the thing as well that kind of, goes us through the next vision of how this information all gets displayed. So what we've done within what we're doing, again, we've kind of spoke about next vision of how we display our vibration analysis information, how we also can start to incorporate all analysis information in the same place, and have an actual information in the portal that allows the site, especially on portfolio level, to see all the asset health is extremely valuable. So say, for example, you're a biogas manager and you've got a portfolio and you're looking after maybe 9 sites, for example. How do you see all of your asset health condition in one place across all of the sites? And we have a beautiful little graphic, right, that I'm going to put up on the screen right now that can show you how you can mitigate all of that within your kind of, portfolio. And that is powered by AquaM Vision that we use. But all of that information is still analyzed by us and a level 3 technician. So even if the guys that are going to site level 1 or level 2 are collecting the information, all of that is getting vetted and screened by a level 3 engineer that is then processed to a place where all of the people that want to be able to see that information can see it, including pictures, assets, the health, the lifeline of these assets is truly phenomenal when you start to gain all this information over time. And when you start to gain all of this, we can even start putting in bearing fault information as well, from pictures, RCAs, studies, feedback loops, as well of us communicating with the site, all within one place, even when all of your sites across the UK could be scattered around. And that brings everything together in terms of reliability and gluing it all together. And that's Nest Vision that looks after the vibration analysis side and the asset health side. Then we've created our own portal for us to be able to also display all of the leaks across all of the sites, whether they've been identified or repaired, in the same feedback function as well that actually Will created as well, which is very impressive. I'm going to put a little screenshot now as well as a little bit of an idea of how that also looks.
It's important because, it's not just about presentation of data, and we have all this really great technology now that we can do that, and we can see all the leaks, and we can see a video and where they've pinned. We can see exactly where I was standing or Will was standing with
that really wowed me when he showed me that. I was like, yeah, this is where the leak was found. I'm like, what is a little geolocation like on the map? It's
great
where the biogas site is.
We can only do that though because the OpGar camera takes the
geo,
at the same time. But all that's really important. It's really nice that we can present it. But what it means that if I was an engineering manager for one of these biogas sites where I might have 7 sites, there's going to come a point where someone is going to be auditing, someone in the Environment Agency is going to be asking, how do you manage your fugitive emissions? This is how we do it. This is our port insight page. This is all the leaks that we've got tracked. This was when we can track within that, when the leak was identified, when the leak was repaired, how many days it took for them to repair the leak. This is really important information to demonstrate to these, the Environment Agency and the HSE, what are you doing to manage your environmental risks and your really explosive risks. What we're doing is we're doing vibration analysis. This is where the information comes. And what it's going to do for those people during those audits, it's going to reassure that you're doing the most you can to ensure that you're not going to hurt somebody or the environment. And then the reliability stuff is all an added bonus for most of these sites.
Yeah, exactly. And that's kind of looking at more the maintenance and stuff like that. So that also kind of rounds up in terms of that biogas package that we offer. And what we're trying to do is able to be able to incorporate them services into a contract. So companies can pay monthly, for them services. So they know that they're going to get their 2 OGI surveys and thermal imaging surveys as well, plus the vibration analysis and being a part of your maintenance team. Yep. That's what we want to be a part of. We want to be that extra eyes, the extra ears, giving you the insight that you need to be able to identify your leak.
Yeah, a lot of these sites, the operators are fantastic in what they do, but they're not trained engineers.
100%. And that's the thing, they're there to operate the site. And this is also where the value comes in, because instead of having to employ a potential engineer at each site, which is probably not viable, if you can get some good condition-based maintenance and some good proactive ways of actually organising that maintenance with good lubrication as well that we can help with and that we can fill in for, then we can make this successfully work with this kind of information as well.
Let us be the eyes and ears, the maintenance, the reliability, trying to look ahead, trying to identify problems before they happen. And then we can let the maintenance teams within the sites that are often on the road, going to different factories, let them focus on the complex tasks that, the remover of a stirrer that is quite difficult. They need to manage that, let them focus on that planned stuff that they know how to do because they've took a stirrer out every year and they know how to do it.
Exactly. And they can mitigate that, and when it does also come down, just another note to the changing of bearings or the repair of, motors and even ATEX motors, we have the Solve team that have really helped some sites out.
Now Harry's done his complex, we've now got 2 big ATEX motors coming in, haven't we?
We have got 2 coming in, and not even that, he's also arranged the fact that when we find these issues or problems, we can be the solution as well to be able to organise and plan out some of this work.
Amazing.
It's difficult, isn't it? Like for some sites to be able to plan things, but what we can do is kind of from the information that we've got is get Harry to come in and say, look, okay, I got a plan for this. We're going to put that spare on, overhaul that, and then a lot of sites also will share spares because there'll be similar equipment on each site.
You're just taking away the problems from them. With this customer you're on about there, 2 of their motors, they both share a spare. They both have issues. We're just going to take that problem away from you. We're going to deal with it. We're going to fix it. And this is how we're going to do it. Great. Go do it, guys. We've got a new app and system that we have got for all tracking the repair centre work and everything that we can keep for an audit trail. And I was going through some of the documentation Harry's created off the back of his complex for all the flame paths. And I was like, wow.
Yeah.
I was like, whoa, okay.
There is a lot of it is.
Make sure the flame path, this measurement, that measurement.
But when I was in the workshop back at Eric's, one of my friends did that course and he did all of it. Very interesting. But it's a lot of work and it's a lot of responsibility as well. You need, this is a big responsibility to be able to have as well, because, it's so important that we get this right, especially in the environments that are explosive. So again, we have to be, and we want to be responsible for that as well. We want to be able to have the due diligence, have the reliability, have the standards to make sure everything is 100% as it should be when we do these repairs as well, because that's what precision is. That's what...
Yep.
you know, precision maintenance is. It's making sure that every single little detail is measured and every little thing that we should be doing is in the process and is followed, and we can follow through with that as well. So, you know, even just going from aside from the biogas package that we have available for the condition monitoring or the tech side, there is a service on the solve side that can come in and obviously be separately quoted from the things we find and have the solution to the problems if you don't have the manpower or you don't have the maintenance. Expertise is able to do so, especially when it comes down to more the electromechanical stuff. I would say the more kind of the stereo replacements or the fixing of, that's more of a biogas industry thing, and a lot of companies do that very well. But we're looking at the precision maintenance of the bearing changes, alignment as well, and laser alignment, so important, especially for gas compressors. A lot of alignment, you know, that you've got some kind of compressor that will be aligned in you know, a coupling, or it could be a belt. We can do all that and make sure that that alignment is improved, the reliability as well. That's Harry's bag. But when it comes down to detect, you know, that's what we want to do. And we also want to make sure that you know, everybody knows what this service is, everybody understands how it works, and everyone can see the value in having us along your side. And we've got now 4 or 5 major biogas companies that we're working closely with a lot of their portfolio, and it's slowly becoming probably more popular than the factory work. But for us, it's not about what type of work it is. If it adds value, and it does, this, you know, for what we've found recently, it's exciting, and we are very proud to be a part of this industry as well. So, guys, if you've got you know, if you've got a site that you want us to come and have a look at, if you've got a site that you want to come and start, even have a chat, even if you just want to have an initial chat about how it works and you want to see a few case studies, then guys, get involved. But I think that's a great way to kind of wrap this up, don't you, Will?
Yep, sounds good.
Awesome. Guys, have a great week. Thank you for tuning in. And now you will see you on the next one. Take care.